Shall we? So we shuru kare. We were actually talking about bases. Acids was done. So let's wrap up bases. Let's wrap up pH scale and everything, so that in next class we can get into salts. Okay. After we finish this chapter, I'm not going into metals and non-metals. Deliberately, I'll go to carbonates, compounds, because if I go it at a later stage, we'll be rushing more on that. That's an interesting chapter. So aram se padhenge, because that's the foundation for your 11th. Okay. So we get into bases. Some discussion we already had. A base is someone who releases an OH plus and has the capacity to eat up the H plus which is there in the aqueous solution. So if you look, we had this discussion. I think we'll just revise. Metals react with oxygen to form metal oxides. Metal oxides react with water to form bases. Bases which are water soluble are known as alkalis. Others are known as bases. So one of the interesting observation is that all bases are alkalis. No. All bases are not alkalis. Only the bases which are water soluble are alkalis. But all alkalis will be bases. In grade 10, the more emphasis is on studying only alkalis. So whether you are using the word base or alkali, whether it is NCERT or any other book, what they are trying to mean is always an base, means an alkali. Not that you are not studying a non-alkali, you are studying everything that is water soluble. Now in that water soluble alkali, you can be completely soluble or sparingly soluble. Okay? Have you understood these two? So let's quickly look at our groups in the periodic table. If I look at group 1 and I look at group 2 and I look at group number 13, which is the one which is quite ahead. Okay. In group 1, the two elements whose bases you will be studying are sodium and potassium. Group 2, you will have magnesium and calcium. And group 13 is one called aluminium. 10th में इससे ज़्यादा नहीं पढ़ते हैं. So sodium's base will be known as sodium hydroxide. Potassium's base will be known as potassium hydroxide. Magnesium's base is magnesium hydroxide. Calcium's base is calcium hydroxide. Aluminium's base is aluminium hydroxide. Okay. Quickly, before going through this, let's quickly write their formulas also. NaOH, and I made you write in the other class that NaOH is also known as the king of bases, also known as caustic soda. Okay, this is also known as caustic soda. KOH is potassium hydroxide, also known as caustic potash. Okay, now since they are in group 1, these will be very strong bases, equally as dangerous as acids. Okay, these will be very strong bases. Now if I come to group 2, I am having my bases. See, OH is always -1. See, OH is -1. This is group 1, so it's plus. OH is -1 plus. Magnesium is +2. Therefore, the OH will become 2 because it has to be -2. Then only magnesium will balance it. This is known as magnesium hydroxide. In our colloquial language or trivial language, this is known as milk of magnesia. लिख के रख दीजिए. These are very helpful for you. Then calcium will form CaOH2 as its base, known as calcium hydroxide and also known as slaked lime. You can keep it written, right? And in group 13, our base will be aluminium hydroxide. Al is +3, so OH is 0,3. These are the ones which you will be dealing more as base in grade 10. Although these are bases, all of them are also alkalis. They are water soluble. But the solubility will be maximum here. This is a strong base, less soluble. That will be even less soluble. Have you understood? Magnesium hydroxide, like all Digene that you drink to digest your food, the bottle, if you don't use antacids every day. So if you see the antacid bottle, the entire medicine will be settled below. And on top, you will just have the flavor, like say ice cream flavor, vanilla flavor. So you're supposed to shake it because you are drinking milk of magnesia. Or people whose bowel movement is not regular, say at ages, then in bio you must have studied, you should have a lot of roughage in your diets. So in that case, milk of magnesia is very good for relieving constipation also. In that case, also you shake milk of magnesia and you have it. And this is also well known. Painters will never immediately paint with this. They will bring nowadays painters are also very stylish. They bring hand blenders. They will blend the complete calcium hydroxide, then filter it, then even blend it and only then they will paint. Otherwise, what you are painting it is only with the lime water part. Okay? So we start with bases. Some of the physical things about bases will be attributed to bases are bitter. Bases are bitter. Any soap that you bite will get a bitter taste, and bases will all be slippery. Bases will all be slippery. Sodium hydroxide, as I told you, is a very good anti-greasing agent. Any surface where you have a lot of oil, say you want to clean your kitchen tiles, your kitchen tiles will never be cleaned good with acids. Bathroom tiles get cleaned with acid very nicely, but the kitchen tiles will be cleaned if you use the red Presto or the Harpic and you just grease it. Jisko in Hindi we say phata lagana. Just give it one and then keep it for some time. All the oil will just get away. Very good anti-degreasing agent. Okay. And primitive talks I have already done. How bases are formed. Metals react with oxygen to form metal oxide. Metal oxides further react with water to form metal hydroxides. Okay. Now some of the reactions of bases. Bases have only 3 reactions, so very easy reactions, but something interesting we will learn in case of these bases. The first reaction is base reacts with metal, again like acid. It will form a metal salt and it will also release hydrogen. It will also receive hydrogen, but this metal salt will be very interesting. Okay, we had studied this. Acid reacts with metal, or metal reacts with acid to form metal salt and releases hydrogen. Similarly, base will also react with acid to base will also react with metal. So let's see the reaction out here. We have a base which is sodium hydroxide and we make it react with a metal which is zinc. Okay, now let us try to understand this reaction first. Okay, you will read this more in salts, but understand what is a salt. What is a salt? A salt usually has a metal part, which is usually the cation, that is the positive ion, right? And it will have an anion part. Do you agree? This is the negative side. So far, when you were forming the salt from acid, say let's take an acid, sulfuric acid. Anion part is to come from the acid, which is to be the sulfate part, SO4. So those salts which you formed were all acidic salt because their parents were acid. One of the parent was acid, so it's an acidic salt. Now the salt that you are trying to form is from a base, so you will say it should be a basic salt. It will be a basic salt, but there will be some stylish thing also. So in salt, the metal always replaces hydrogen. Many people say, what is a salt? A salt is something in which the metal has replaced the hydrogen from the acid. Try to understand. I have an acid H2SO4 and I'm reacting it with zinc, right? If the zinc goes and displaces this hydrogen away and it forms ZnSO4, that is salt. But this definition holds very good if you are talking in terms of an acidic salt. But when we talk in terms of basic salt, that is what we are trying to talk here, okay? We will have a different type of ion. Okay, can I rub this portion? So let's see what is the interesting thing that you will see. Now you know some, though in salts we will study family of salts. Like you have got the families, the Reddy family, the Saxena family, the Malhotra family. So here also you have the carbonate family, sulfate family, nitrate family. So here a new sort of family comes up, ZnO2. This ion is known as zincate. Zincate. Okay, so let's see. It is an ion. I have not yet put the charge. Can you help me in putting the charge? Oxygen is 2 minus. 2 oxygens. So how many? 4 minus. Zinc is 2 plus. So out of 4 minus, 2 minus have been neutralized. What is left is 2 minus. So zincate is an ion which is ZnO2 minus. This is an ion. It's an anion. And this salt will be formed, which will be known as sodium zincate. So I will have ZnO2. Obviously, it is 2 minus, and sodium wants to pair with it. So how many sodiums will come? 2 sodiums. because 2 sodiums each is giving plus. This is called sodium zincate. Very interesting salt, which you will study again in metals and non-metals as well as in salt. Sodium zincate is called an amphoteric salt. There are two amphoteric salts, sodium zincate and sodium aluminate. We will study later. What is amphoteric? Comes from the word amphibian, an organism which can live both on land and sea. So this is a very dangerous. It can behave as an acidic salt also. It can behave as a basic salt also, depending on with whom you are reacting. These are called amphoteric salts. We will read about them. So one amphoteric family is the zincate family. One amphoteric family is the aluminate family. We will read the aluminate when it comes. Now don't break your head. So balance this. So we will have 2 of NaOH. I think this is balanced now. Yes. And you get hydrogen. So what did we study? Bases react with metal. Not all bases. So some bases will react with metal. And this is one classic example that we see. Forms a salt, because the question may come, a base on reacting with a salt, a base on reacting with a metal forms an amphoteric salt. The same metal in that salt, when it reacts with an acid or has the capacity to displace copper from copper sulfate. So they are trying to attack you on zinc and forms a layer of white layer over the copper sulfates, copper strip or copper sulfate. So are you understanding how the questions might be jumbled together? Because the metal involved here is zinc. You have read displacement reaction, Zn plus CuSO4, ZnSO4. Means in CuSO4, if you dip a zinc stick, blue color will be lost and the zinc strip will start forming copper on its top because copper gets released. So sab kuch yaad rehna hai. Is this clear? Second reaction that we see is a very common reaction, which is R, which we study in both. It is a characteristic reaction of acid as well as base. So you should know that is the neutralization reaction. Neutralization reaction. What is a neutralization reaction? An acid reacts with a base to give you salt plus water. Remember, this reaction is highly exothermic because you are having two powerful guys contesting with each other. Right. So let's see this reaction in our normal way. So let's take an acid like say H2SO4 and let's take a base, say sodium hydroxide. What do you expect? So since we are targeting it from neutralization reaction, let's see the neutralization. This fellow will split into what? 2H plus SO4, 2 minus. Got it? This fellow will split into Na plus and OH minus. The NAs and the SO4. SO4 is 2 minus. So one Na cannot marry SO4. So I need to put a 2 out here, which means I'm getting 2 and 2 out here. Is this understood? Let me make this more clear. So this makes it 2OH minus, right? So let's see the neutralization. The neutralization will be happening. The neutralization will be happening between this fellow and this fellow. These two will neutralize. H plus OH forms what? HOH. What is HOH? Water. So you will be forming 2H plus OH minus, which is nothing but 2H2O. Do you agree? And these two will combine to form the salt, Na2SO4. So that's how it comes. Na2SO4. What should be the name? Belongs to the clan of sulfates. Sodium sulfate and 2H2. Mechanism, have you understood what happens in this reaction? The acid will dissociate into its ions, that is hydrogen and sulfate. And similarly, who will dissociate into ions? The base will dissociate into the metal ions on the hydroxide ions. Hydroxide ions have an affinity for hydrogen ions. They will combine to form water, and your metal ion and anion from the acid will form the salt. Is this getting clear? No issues. And water formed will be denoted as liquid. This is aqueous, and the other one is also aqueous. And the last type of reaction, very easy. Bases have only 3 reactions. Shall we see the last reaction? Okay. Our last reaction will be, there will be still some base which will react with non-metallic oxides. Non-metallic, you know this reaction actually. Non-metallic oxide. And it will form a metal salt and will release water. You know this reaction. You have dealt it many times. Base, calcium hydroxide. What is the trivial name for this? Silicate lime. Bring a non-metal oxide, carbon dioxide. You know this reaction? Yeah. So this will form what? Lime water turns milky, calcium carbonate, and will release water. Calcium carbonate, how will you give the states as? This will be aqueous, this will also be aqueous, okay? Although this will come down as precipitate later, this will be liquid and this will be gas. Are we fine? On basis, अब थोड़ा फंडा क्लियर हो रहा है. Slowly you should be knowing the names of all type of acids. Now tell me one thing, are you very confident with somebody tells you what is nitric acid? You can write the formula HNO3. Nitric acids will give the family of salts which are known as nitrates. Nitrates with group 1 will form MnO3. Will group 2 will form MnO3-2. Will group 13 will form MnO3-3, because nitrate is always NO3 minus. Let's see a hydrogen chloride, HCl. So Cl minus, with group 1 it will form MCl. With group 2 it will form MCl2. Group 13 it will form MCl3. Then let's see another acid which is sulfuric acid, H2SO4. With group 1 it will form M2SO4. With group 2 it will form MSO4. And with group 3 it will form M2SO4 whole 3. Crisscross, LCM, because this fellow is 2, that fellow is 3. You have to make it 6. The metal is 3 plus, aluminum is 3 plus, the anion is 2 minus. So give the anion 3, it becomes 6. Give the metal 2, it becomes 6. Right? Another acid, what more acid? Like we have carbonic acid, H2CO3. H2CO3. CO3 means 2 minus. So with the first group, it will form M2CO3. With group 2, it will form MCO3. And with the last one, it will form M2CO3 whole 2. Right? M2CO3 whole 3. Done this much. Couple of discussion, little bit more on strong base and weak base. Do not attack it as base. You go by your basic funda. Does bases conduct electricity? 100%. They release ions. So they are electrolytes. Go by the definition of electrolyte. What is a strong electrolyte? A strong electrolyte is one which dissociates completely. And whose alpha is almost 95%. And a weak base is one which does not dissociate completely. Right? So if I go for a strong base, right, and you take the base with water, anyways, we'll discuss it later. A strong base is one which dissociates completely and has more of OH minus. A weak base is one which will not dissociate completely and will have less of OH minus. Here the OH minus will be much more. Whereas in the case of a weak base, the OH minus will be much less. Clear? Any doubts or anything till here? No. Shall we then move to something called the strength, how you measure strength? Now that will deal a little bit in detail, though not in syllabus, but we should understand. Our next topic is to understand the pH scale. Nowadays, people talk a lot about it. You go to a beauty salon, even the beautician will say the pH of your skin is less. Everyone talks about pH, pH, pH. You will also say, but what is actually pH? We should first understand, okay? In order to understand pH, you should look at water first. Water, if you slightly acidify water, electrolysis cannot be done on water. Electrolysis is done on slight acidified water, either by adding salt or an acid. The water will split into H plus and OH minus. Water being neutral, the count of H plus and the count of OH minus exactly match each other. And in grade 11, you will study something called the ionic product of water. Ionic product of water. And you will study that it is into 10 to the power 14 karke aap padhoge, right? 10 to the power 14. Don't break your head on that. Now what happens if you start, now this is water and I have started to add one acid into it, right? What does the acid bring with it? The acid brings the anions also. Let's forget that. But the acid is coming with a lot of H plus with it, right? There is a pool where there is equal concentration of H plus and equal concentration of OH minus. Okay, let me tell you a story of our childhood. It will be very easy. So in our childhood, we used to get these cream biscuits. We never had like Oreo and all. So we used to call cream biscuits. Biscuits which are rectangular or round have an orange cream. So we were not that much sophisticated. So the way we used to eat it is first open and only eat the cream. And the discs or the rectangles used to be left. So my mother used to say, who is going to eat those? The dog of the colony or what? Once somebody has to eat. So imagine if a hungry child of my day used to come when we were not entitled to so many things, we will first come and eat what? We will come and eat the cream. So what will be excess now? The biscuit discs will be excess. So there is equal amount of cream and biscuit right now. Agreed? And a boy is coming with a lot of H plus. These H plus will immediately first neutralize this OH minus as what? Water. As water. Agreed? But he still has some much more H plus, and there are some more H plus out here itself. So what does the solution have more in excess? H plus. It has turned base acidic. If you bring a base out here, a base comes with a bag full of OH minus. Those OH minus will actually eat up this H plus, leaving the solution with plenty of OH minus. So that's how you turn a solution acidic or basic. Have you understand? That's how we turn a solution acidic or basic. Now in grade 10 CBSE, they don't make you define what is a pH. But if you want to understand, well, you'll not understand anything. pH is like testing the presence of H plus. In grade 12, 11, you will also study something called POH. Why should you only look for good boys? There is a group. Your hunt is for good boys. There can be bad boys also. If you count the bad boys, you automatically know what are the good boys. If you know the total count, are you understanding what I'm saying? Out of 100 boys, if there are 20 good boys, so how many bad boys? 80 bad boys. So why don't we count the 80 bad boys? So how many good boys? 20 good boys. But the notion is that we start attacking pH. pH means basically you are hunting for the acidity of the solution. POH means you are hunting for the basicity of the solution. Have you understood? A pH is actually, the pH means pH plus. A pH is actually defined as the negative logarithm of the concentration of hydronium ions. You will not understand what it is. Just for then only you get that number. A negative log of hydronium means your hunt is for H plus ions, right? And this is a scale which was given by a person whose name was Sorensen. Now log is a very interesting scale. Log is a very interesting scale. A log scale helps you map. Now pH tells you what? pH tells me this is concentration. How many ions are there? Are bhai, with your naked eye, can you see ions? These ions must be in crores and crores of numbers. 10 to the power so many. How do you count? In that, a log scale comes into use. So let's see that log scale also. Okay, just for interest purpose. I tell you, take a graph paper, and in that graph paper, you plot the distance from your flat to my flat, the distance from my house to Anurag's house, some kilometers. You also show me the distance to moon. What axis will you take for the x-axis? And you also show me what is the diameter of an ant's eye. Is it possible? It will be a very strange scale. A whole graph paper will not work. But look, if I change the x-axis something like this, if I now start plotting my x-axis as, say, this is, say, 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3, 10 to the power 4, 10 to the power 5. Don't you think I can plot everything that I spoke so far? The distance to the moon is 3,84,000 kilometers, can be plotted here, right? And I now change this axis as 0, 1, 2, 3, 4, 5. Means I'm basically dealing only with the exponents. This is a logarithmic scale. The Richter scale in which we measure earthquake is a logarithmic scale. You might say, "Arey, their city, it had only Richter 3 earthquake. Hamara bhi paas hi tha, very close, 4. No, you idiot. They had 1,000 and you are having 10,000. Are you understanding? Richter 4 and Richter 5 is a huge difference because this is a logarithmic scale. pH scale is also like that. And when you study log, you will understand about it. Okay? So a pH is a scale which gives me exact count of what is the number of either H plus or H minus. So the pH scale was designed by Sorensen. He designed it like this. He designed it in this manner, where the scale starts from 0 and ends at 14. That comes from the ionic product of water, which is 10 to the power 14. Means 10 to the power 7 number of will be positive ions, 10 to the power 7 numbers of OH ions. This is a scale. This is a pH scale. And what is the mid of this scale? 7. At 7, the scale reads a solution as neutral. So if you are water, your pH should measure how much? 7. 1 minute. ये नहीं है, मैं आपको बी टावर के मैं दे दिया ना आपको, बी टावर में सेम फ्लैट है मेरा. हाँ, आईपेंडा, थैंक यू. Okay, so now look here. This is called neutral at 7. Now you ask yourself, why did I become neutral at 7? Water. Ionic product was what? 10 to the power 14. 10 to the power 14 means how many hydrogen ions? These are all not there in your 10 syllabus. Then only you understand this. That means hydrogen ions are 10 to the power 7. And how many basic OH ions? 10 to the power 7. Add both, it becomes how much? 10 to the power 14. So if you are hunting for hydrogen ions in water in this scale, how many hydrogen ions should be there in water? 10 to the power 7. So at 7 you are neutral. Did you understand this logic? This is a scale which is designed from 0 to 14. At 7 we designate you as neutral. Why are we designating you as neutral? We are designating you as neutral because we are hunting how many H plus are there in you. You being water, your H plus and OH minus should be balanced. So on a scale of 14, how, suppose you want to, there are brothers and one brother, one sister, they keep on fighting, but you are very rich. You want to buy 14 dairy milks. How many dairy milk will you give to the brother? 7. How many to the sister? 7. Similarly, same. I am hunting for number of dairy milks with the brother. In a house where I will be buying 14 dairy milks and I have got only 2 kids, so that there is no fighting between them and my love is disproportional. How many dairy milks should I find with my daughter? 7. And how many with my 7? So if it was a pOH scale, then also water will read at 7. But we read it by, we will always count how many dairy milks with the daughter. Beti bachao. We can also read as how many dairy milks with the sun. But that scale you will read in 11, which is known as POH. Got it, na? In the house, there is OH and OH. We will read by H. We will not read by OH. That is the standard protocol. Is this understood? Very good. So, when you go to 14, at 14 you are 100% basic solution. Dangerous. Very highly basic. And at 0, you will be 100% acidic. Now it makes you a sense. The sense is that if you are a weaker acid, now see acidic, less acid, less acid, less acid, less acid, less acid, water, basic, very basic. And come from this side, basic, and water, acidic. Now one more interesting thing. All of us sweat, right? Now you'll love this example. If you sweat, everybody will release a sweat odor, which is normal. Now, what is abnormal is you not taking precaution against that odor and you still carrying that odor in you. So, as I told you, when you are actually sweaty and you have released sweat, then when you go to the bathroom and you start showering yourself, you're using what? Soap. Soap is basic. And once you soap your body, the body odor goes away. That means what was your body was something like the body must have become acidic at that time. That's why the soap is able to neutralize your body. Now see, beautiful thing. Have you heard this? Have you heard about this brand, Johnson's? Makes so many baby products. तुम्हें तो बड़ा मजा आएगा. Johnson's, he's crazy. Johnson's used to make a deodorant. Now I don't find it in the market. It is very much there in US. So Johnson's deodorant, you know what was the brand name? The brand name of this deo was pH 5.5. It is sold as Johnson's pH 5.5. pH 5.5 means some acidity is necessary in your body. So it is, if you sprinkle that deo, your pH will be here. You won't smell out from your body. Such a nice product. You can still Google on internet. It was sold in India when in our school days also. Now I don't see that brand. Johnson's pH 5.5. Lovely fragrance. There were two fragrances as boys we used to like in our teenage days. One was this and one was Do It. Do It is still available. You won't see it on Amazon and all. It will be flesh color. Wonderful deo. And again, अरे लड़कों लिख लो काम में आएगा तुम्हारे college days में. Another is Brut. This is a little bit on the expensive side, but you get a lot of fake Bruts. If your Brut is green color with a black cap, anyone goes to US, you ask to bring Brut. Yes. Yeah, please, darling. Who stops you from water? Ye teen means this is to be your party night perfume. Brut, or you can use Do It. Those perfumes are very costly. And that's why nobody, if you are sprinkling deo on your clothes, you are another super idiot. A deo is to be put on your skin. A perfume can still go on your clothes, but still on the hot zone only. Not on these. So anybody sprinkling deo on clothes is an idiot. Deo should be always on the body. Okay? So Johnson's pH 5.5. Now some more interesting things when you go about this. Have you heard? Now somebody says, we don't drink RO, we don't buy bottled water, we buy basic water. Anybody has heard that? Like people are very health conscious. We eat ragi dosa only. We eat organic dosa. So there was a lot of talk which is happening 2 years before basic water. Basic water. Basic water is water which will come in this bottle. Even in our apartment also there is a supply of that bottle. That water will be having more of OH minus. Question arises, sir, why do we drink that water? The Russians always say, if your body is basic, in fact, they challenge it. There is a lot of things that happens in this cosmetic world, which we don't feel. All the best of the lipsticks are made from fish scales. I hope you know that. The best of the lipsticks, Maybelline or whatever you're using, are actually made up of fish scales. So whether you are a vegetarian girl and doing this, you are actually rubbing fish only on your mouth. Okay. So now the good thing is, Russians say if your body's pH is negative, if you're negative means if your pH is basic, you're on this side, cancer never happens to you. And these artifacts are found. America is a very capitalist economy. They will sell their products like anything. Okay, I'm digressing, but still you should listen. When I was in grade 5 or 6, as a Bengali in our house, the cooking oil was mustard oil. Then came this concept of cooking in. All these companies started. India signed GATT, General Agreement on Trade and Tariff, in the year 1992 when the Indian economy was opened. Before that, in India, buying a Sony TV was a big issue. After that, all these brands started coming in. Everybody started saying, eat refined oil, sunflower, Vital, and all. And they started poking up a story that mustard oil causes heart attack and all. So much so that overnight I saw the costliest oil in our days used to be a Postman oil, blue color tin. You can ask your mom and dad. These are the best of the oils for eating. And this market, then they said cornflakes is good for you and all. Imagine, did your forefathers die by having, they used to have puris in ghee, in oil, nothing happened. And today the same doctors say, please continue with mustard oil or the oil that you are eating. And they say, the Indians used to eat a lot of rice, nothing happened. Once this capitalist economy starts going, all these fragrance and all the perfumes that you use make you a very handsome or a very charming lady, but is maintaining your body at a very acidic level. And once you are acidic, you are prone for infection. That is what happens to your tooth. If your tooth is acidic, you sweat. In the scorching heat, the farmer is sweating. He might smell in his body. He does not fall ill any day. You fall ill. So Russians say, cancer cannot happen to you at all if your body is basic. But if your body is basic, you do not look that charming lady or that handsome person. So all these things are also, any sort of product, when it gets into the market, the product is also trying to make you a victim of that product. Eating too much of frozen item. Is cheese bad? Not at all. Is frozen food bad? Very bad. They all have additives. Want to eat a chicken? Eat a fresh chicken. Want to eat fingers, fish fingers, veg fingers? Make it at home. But we don't have time. We will buy that pack of momos and then steam it. How is that pack of momo remaining fresh? BHA, butylated hydroxyanisole, those will be there. And BHT, butylated hydroxytoluene, antioxidants are added to it. They are antioxidants. They are added to all these foods which are prepared. You go for these, I won't name because we are recording, but when you go for this, buffet lunch, $7.99, you mean to say all chicken got consumed? Evening, the whole restaurant will run as a la carte. Means you'll buy each item. Every chicken got consumed at night? No. Will they throw it? No. So they cook this food with antioxidants so that the food does not get stale. Because there, a whale will go and pick from this side, you will go and pick from that side. It's supposed to get bad, but it doesn't get bad. It's still yummy, amma, so tasty. Please, from this age itself, I'm saying the only frozen that you should have is maximum is an ice cream. Avoid anything that is frozen. Frozen fries, frozen McCain, veggies, and what? Potatoes, garlic potatoes. Mat kha. Make it, eat it at home. Fry so many potatoes and eat. Not that good, but it is much better than emptying that packet and eating it, right? So if on this part I will be what? Mildly acidic, and out here I will be mildly basic. Now one question to you. If I ask you that try to plot sulfuric acid on this chart, which way will you plot? You'll plot it this way. Try to plot citric acid on this chart, maybe somewhere here. Lactic acid, maybe somewhere here. Citric acid is still, it's still tangy, right? Try to plot magnesium hydroxide, maybe somewhere here. You still drink it. Try to plot calcium hydroxide, maybe here. Try to plot sodium hydroxide. Both on these sides are dangerous. The Devta and the Asur. Here it is Janakalyan. Narrup. Clear pH. So pH 3.3, what should be the solution? Acidic. pH 12.8, it is almost going to a strongly basic. Okay, and pH 7 will be water. Okay, so nowadays what we design, this is called the pH scale. Now we have something which is known as the universal indicator. More stylish. Acha, how many of you have blood sugar measuring device at home? Okay, and you have that stick wala measurement. Okay, so what do? You puncture your finger and then you put the drop on a stick, and that stick is actually inserted into the meter, and the meter gives you a reading, right? So if the meter was bad, the stick packet from where you are taking out that stick, common brand is AccuCheck. Okay, if you see that dabba, or it will have something called a color indicator chart also. Color indicator chart. Suppose your digital machine is not doing good. Once you put the blood sample on that particular stick, there will be a central portion on the stick where there is a pale greenish color, and the color keeps on changing depending on what is your blood sugar level. Okay, what is your blood sugar level? And blood sugar is measured in the unit of milligrams per deciliter. So there will be a chart where it will be green, light green and all, and they will give you range. That is a universal indicator. A universal indicator is not something like litmus is a universal indicator. It can indicate both, right? But if you take say phenolphthalein, phenolphthalein does not indicate acid. So universal indicators, we say, are a mixture. They are a mixture of dyes, and they show different shades of color in response to acids and bases. And so much so they have been designed, that the universal color is also this way. The scale will be designed in such a manner that on this end of the scale will be, the colors will be slowly turning, say from sky blue here, and the scale will show extremely deep, it will show completely deep blue color out here. Because you know the litmus behaves as blue means basic, right? And the scale will have an extreme bright red on this side, red, mildly red, orangish, yellowish, then it will become green out here, showing you neutral. Green will fade to dark green, light blue, deep blue, and darkest blue. So this is the easiest one that we use in labs nowadays. This side will be acidic, and the color is maintained in accordance to the color code that we follow for litmus. Have you understood? So universal indicators are a mixture of dyes. Now you need not do anything. You just take this dye, this universal indicator, which is like a stick, and on that you drop one drop of your solution, whichever it is. It will show a color in this band. I'm not able to draw the complete color. You'll see in your book. It will be red, mildly red, pinkish, yellowish, green. So if you see citric acid, it will be slightly in the yellowish side. Whereas if you take sulfuric or nitric acid, it will be pitch dark red. If you take potassium hydroxide, it will be dark blue. And if you are a little bit, say, water to magnesium hydroxide, it will slowly get into greenish zone onwards. So this is called a universal. You know, universal indicators are also used like, see, you all don't do practicals. That's the wrong thing. Test the presence of starch. To test the presence of starch, we use something called iodine. Yeah, iodine, if you add, it will become blue. Now, if you take sugar solution, there is another solution available called Benedict's reagent. Benedict's reagent, B-E-N-E-D-I-C-T, Benedict's reagent. Benedict's reagent, if you put 1 or 2 drops on any water solution, then it will immediately be any sugar solution, the solution will become blue, indicating that the chances of you carrying sugar is very high. Now, the person who is diabetic, what do we test? We always test fluids, and we'll say fluids, or we can say body matter that has circulated in our body, like the circulated blood. Therefore, you always puncture the vein. Intravenous artery, you will be puncturing the artery, you will be puncturing. One will carry the pure blood, one will carry the impure blood. We want to test the impure blood. It has circulated in your body now. We want to test that. Another fluid we can test is urine that you test. So when you do complete urine examination, which in pathology is known as CUE, there are two tests which people commonly do: CBP, complete blood picture, and another is called CUE, complete urine examination. So they can test the whether you are diabetic or not in your urine also. So they will take a mild, what you call dilute solution of the urine, and add Benedict's reagent. And then you are slowly supposed to heat it over flame. We have done this in our labs and all. So it will give you that coloration. Similarly, for these people who are reluctant to puncture and have fear, we have sticks which you can use with urine also. That is called diastics. It is available like a pack of sticks. If you dip it in right sample of urine, the diastics will actually immediately form a color, and on the packet there will be a reference color chart. Match it with that reference and you will see you are reading at 120 or something like that, which means your sugar level is right now at 1. At this age, you should know some things. I mean, it's good for your health. There is a test called FBS. How many of you know about it? FBS is known as your fasting blood sugar. If you have any elderly person at home, you will see the person comes empty stomach, they will take this sample. At a normal level, your FBS at this age should be something around 80 to 90 milligrams per deciliter. This is your fasting blood sugar. Whole night you have eaten, body has digested, and now your FBS test is taken. After the FBS test is taken, then the person will say, Amma, after breakfast, 1.5 hours. So they will make you eat nicely now. Don't ditch the test. Eat your normal meal, 4 idlis, 1 dosa, and wait for 1.5 hours. Again, take a blood sample. And, oh, bhai sahab, you are awake? What am I teaching? Yes. Okay, very good. So that is called BS and we call it PP. This is a medical term called postprandial. That means after eating. This for a normal person should be around 120 to max 120 only, 135, 40, not more than that. If you are reading more than that, then you are diabetic. Your body is not secreting enough insulin, is the hormone that pancreas secretes. I know biology, that dissolves your blood sugar. So your body is not giving insulin. So what happens at our age? At our age, the pancreas becomes weak and it is not supposed to push in that much of insulin. So the sugar is now remaining in my blood. I become diabetic. So the first way of they will say is behavioral wellness. Start walking, less of sweets. As my doctor used to tell me always, there is only one medicine to keep people who love food. That is, put medicine in the eyes. Don't look at food. Don't look at sweets. Walk. That is called behavioral, stage 1. If you cannot improve with that, they will give you tablets, carbos. That is stage 2. And stage 3 comes insulin injections in your tummy. So you are injecting insulin. And once you take this, I've very less seen people coming out of this. You'll be in this only. So you get. Now, many people may say, sir, yesterday I ate a lot of sweets, sir. I went to Jaideep's house. That's why my reading is coming good. So you have another test nowadays called HB1AC, glycosated hemoglobin. This will give you an average of your 3. Generally, companies who hire now do not go by these tests. They go by this. This has nothing to do with what you ate yesterday. This will give you a 3-month average. Anything about 5 is you're getting into diabetic, which like I should be very careful. I'm just hitting now at 4.6, 4.3. My dad has been diabetic. So that means I carry that genes. Have you read about alleles, dominant and expressive? You have not read? In grade 10 you have that. Yeah. Yeah. Dominant genes, and every gene has got alleles. A dark person may give birth to a fair child also. That means the fair child also carries the biology. Fair child also carries that dark genes. That's called, in my case, my complexion is dark. So in my case, that gene is more dominant. My sister is fair. So in her case, the dark gene is repressive. So HB1AC, I carry, my dad has been diabetic, means I carry that gene. It has been repressive so far. It might show its dominance now, which is the age. So HB1AC will track your 5 months of 3 months average they will give you. It has nothing to do with what you ate yesterday and what you ate today. So all these tests are based on universal indicators only. Glycosated hemoglobin. ये सब जानना चाहिए आपको. Then you have got a test called lipid profile, which will see what is your fat content in your body and your livers. So you should, because diseases attack at a very early age from now. So be careful. Once you are teens and you are into 17, 18, keep a check on these. Okay, ये समझ में आया? That's all about acids and bases. We have nothing more to discuss. Universal indicator related questions will come based on colors. Till now, any doubt with anyone? So stronger a base, more will be the number towards, okay, if the pH value is more, that means you are more basic. If the pH value is less, you are more acidic. And in grade 11, you will study pOH. If the pOH value is more, you are more acidic. And if the pOH value is less, you are, so don't confuse between yourself. चले कुछ questions करते हैं. Are we ready? Come on. चलो. It says, we have two solutions. I have two solutions, and a solution is a solution A, another solution is solution B. Okay. The pH of solution A, if I look at the pH of it, pH is written as a superscript, children. You know what is superscript, right? Yeah. This is 6, and the pH of solution B is 8. Okay. The pH is 8. So he's asking, based on this data, what do you read? Who is acidic, who is basic? A is acidic, B is basic. But the question will not be so simple as you think. They're asking you now, which has more hydrogen ion concentration? Who has more hydrogen? Acid has more hydrogen concentration. See, that's what. You'll immediately started answering A. Imagine there was a person who, a commerce child also sitting here. Answer in a manner so that that guy also enjoys the discussion. You should say, as acids contain more of hydrogen, so it's A, which is acidic, is the one which carries more of hydrogen. ठीक है ना? खाली A भी ऐसे गया. Which of the solution is acidic and which is basic? Well, you can answer that. Okay. Now there are 5 solutions. Now we have 5 solutions: A, B, C, D, and E. There are 5 solutions with us, which are A, B, C, D, and D, and they are reporting a pH of 4, 1, okay, 11, 7, and 9. This is the pH that they are. So, which is neutral? D is neutral. Okay, fine. Which is strongly alkaline? C. Strongly alkaline means strongly basic. C. Very good. Which is strongly acidic? B. B is highly acidic. Falls on your face, kiss yourself goodbye in the mirror. Okay. And the next one is weakly acidic. Weakly acidic. And weakly basic. This is very interesting question. A strong acid is a very weak base, right? And a weak base is a very strong acid. A strong base is again a weak base. But they are saying weakly acidic. It is still acidic but weakly. So you should be looking at 7 and the one closest to 7. Who is the one closest to 7? I think 4. 4 is acidic but is weakly acidic, right? And how about weakly basic? 9 will be weakly basic. But who is the weakest acid out here? Weakest acid. C is the weakest acid. And who is the weakest base? B is the weakest base. You have named him, he's a boy end of the day. You are targeting him as good boy or bad boy. And you know he's a bad boy. So you will say, who is the weakest or who is the most lowest cadre good boy? The best bad boy. That way you should answer. Yes or no? Okay. So let's see some more question. Okay, that's done. pH in our daily life. pH in digestive system we have discussed. pH as a cause of tooth decay we have discussed. pH in animals and plants which are also sensitive, like nettle plant, you know. Then ants self-defense So whenever any plant is actually injecting anything as self-defense, they are actually giving out either an electric shock to you or an acid to you. So like the eel fish, eel releases a lot of voltage. Okay. Similarly, nettle plant will release acid. The ant will give you a bite which will release methanoic acid, and wasp is actually releasing a base. So that's there. I think some more questions. Okay, some fill in the blanks. Let's see. Acids have a pH dash than 7, dash than 7, lesser than 7, lower than 7. Very good. Acids have a pH, alkalis have a pH dash than 7, greater than 7. Okay. Neutral substances have a pH which is 7. The more acidic the solution, the dash the pH, the lower the pH. The more alkaline a solution, the dash, which is okay. Okay. Now, what color will an universal indicator show if you add to it the following substances? So the substance that I'm going to name out will be either acidic or basic. If it is basic, it is going to show you a bluish color, dark bluish color. If it is acidic, it will show. So number one is potassium hydroxide, group 1, caustic potash. Dangerous alkali, means very strong. So it will show you dark blue. Okay. Soda water. Soda water. Soda water. It will be anything water. It is almost taken as neutral. So mildly, almost greenish in color. Greenish because you are at the middle. Sulfuric acid. Dark. Okay. Next question. Two solutions X and Y are tested with a universal indicator. Universal indicator need not always be a stick. It can be a solution also. It's a mixture of dyes. Two solutions X and Y are tested with a universal indicator. Solution X turns orange, whereas solution Y turns red. Red, orange. Which of the solution is a stronger acid? Y. The one which has turned red, it is the stronger acid. The one which has turned orange is also acidic, but comparative to X, it is less acidic. Okay. Now, two solutions A and B have pH value of 3 and 9.5. 3 and 9.5 means one is acidic and one is basic. Okay, fine. Which of this will turn litmus solution from blue to red? Who turns blue to red? Acid. Red is khatra, yaar. Acid turns blue to red. So the one with the pH value as 3.5 will be turning litmus from blue to red. Okay. And which will turn phenolphthalein from colorless to pink? A base turns phenolphthalein. The one with the pH of 9.5 will turn. Okay. The pH of a soil is 7.5 and a pH of another soil is 4.5. Two soils we have sampled. Which of the soil A or B should be treated with powdered chalk to adjust its pH and why? Powdered chalk is base. You will add base to that soil which is acidic in nature. So the soil with a pH of 4.5 will be treated with powdered chalk in order to reduce its acidity and bring its pH towards neutral. Don't write reduce the pH. Increase the pH because it is at 4.5. You will bring neutrality by increasing the pH to 7. Yale, English is very dangerous out here. If you are acidic, to make neutral, you increase the pH. If you are basic, to make it, okay, if the soil was basic, what will you add? More of compost, cow dung, whatever, biomass is all acidic. Add them more to reduce the pH and to bring it. So whenever we say reduce your pH, we are wanting you to turn you acidic. Increase your pH, we are turning you towards basic. In this journey, you will cross over a fuel station whose name is water, who will be the neutral point. Once you cross that LOC, you are getting inside. Next class, we get into salts. Maybe two classes or 3 classes in salt is maximum. We'll end this chapter and then we'll move to carbon and its compounds. We'll take more time in that chapter, right? And at last we will do metals, because metals and non-metals is a very nice revision of the first 2 chapters. Okay, children, enjoy your so-called holiday. Anurag, today you did not bite your finger once also. I'm so unhappy.